In this video, I will talk about two parts. The first part is how to prevent rusting, and then the second part is about different factors that will speed up rusting. Okay, so first, just record. We know that, the necessary condition for rusting to occur is the presence of oxygen and water. Okay, so now, in order to prevent rusting, so if we can either brought O2 or brought H2O, from iron, then actually we can prevent rusting. Okay, so now let's have a look about the first method of preventing iron to become rust. First method is by coating. Coat something on the surface of iron. So for example, we coat it with oil, or we coat it with some paint. So once the iron object being coated, then what will happen is O2 and H2O cannot reach the iron object, and so that it can prevent rusting. For example, if we put oil here, what will happen is, so if there's oil, everywhere here, then oxygen and water cannot contact with my iron underneath the oil, so it can prevent rusting because these two cannot contact with iron. So similarly, for painting, or even coated with a plastic layer, or coated with another kind of metal, so coating something on the surface of iron, so this prevent rusting. I think this is not that difficult to understand. So by coating an oil, oil can also function as lubricant. Lubricant, 潤滑劑啊. And then you have to know, in under what situation, so what kind of coating should be applied. For example, if we are talking about some moving parts, then of course you can only coat it with oil. You shouldn't coat it with paint or plastic layers, because those layers will be easily fake off when the iron part is keep on moving. So even for bicycle chain, 單車嗰啲鏈啊, so you also use oil as lubricant and also as a protecting layer, for iron. So then have a look about coating with other kinds of metals. So there are some common metals that can be used to coat the surface of iron. For example, coating with zinc. Zinc plating. Plate, that means coating. So but we seldom say zinc coating. We say zinc plating. Plate something on it. So zinc plating is used to protect bucket. 水桶啦. So we coat a layer. Let's just like this one. We coat a layer of zinc on the surface of it. So this process is also called galvanization. Galvanization means zinc plating. Or we can coat it with tin plating. So just have a look about a food can. The inner part of food can is actually coated with tin, because iron, actually they can easily react with water inside, so they will be rust easily. So if we coat it with a tin layer inside, so tin layer is non-toxic, at the same time is less reactive than iron, so that it can protect the inner part of the iron can. And then chromium plating. Chromium is very shiny metal. So it's used to make the luxury bathtubs. 一啲水龍喉咧，你見到好閃嗰啲咧。So they are coated with chromium. And actually, those kind of bathtubs can be very expensive, just like $3,000. For a bathtub. So it's very expensive one. And then you can make silver plating. On trophy. 一啲獎杯上面啦。So these are the first method of protecting iron from rusting. So the second method is called sacrificial protection. Sacrificial, 犧牲保護啦. So there are some common metals we use in sacrificial protection. So what's the idea here? So if you remember the reactivity series, so iron is here. So, and then we just recall about the rusting. What are the steps involved? So you can refer to your notes again. For rusting to occur, actually the first step involving formation of iron 2 by donating electrons from iron object. So iron donate electron to oxygen and water in the air. Now, if I have other metals provided. Okay, so just like potassium, sodium up to zinc. So what will happen is, if oxygen and water, let's say here, okay, oxygen, water, okay, so these two molecules would like to get the electrons and become hydroxide ion. So actually we have many options. So which metal can donate electrons to water and oxygen? Of course, it should be the more reactive one. So it means that if I have an ion object, but at the same time I have the more reactive metal, just contact with it. So oxygen and water may get the electrons from these metals. Okay, so let me show you in a more detailed way. Let's say, okay, wait, okay. So let's say I have a iron. Okay, so wait, let me remove this. Okay, I have iron metal. Okay, so each iron atom should combine with 2 electrons. So we have iron 2 and electrons. So together make a Fe atom. And now, if I contact iron with zinc metal, so I need 2 more electrons. Okay, let's say here. Okay, so they are directly contacting with each other. Okay, so this electron belongs to zinc, this 2 belongs to iron. So what happens is, if O2 and water comes, okay, let's say, okay, can you see O2 and H2? Okay, let me put it this side. Okay, so what will happen is, O2 and H2 may get the electron to become hydroxide. Okay, so now if they move to the side nearer the iron, so what will happen is, these 2 electrons will be given to O2 and H2O, and for my iron, it will become iron 2. So that will be the first step of rusting to occur. Now we would like to prevent this one to happen. What will happen is, because iron directly contact with my zinc. Okay, so just think about the case again. So H2 and H2O and oxygen comes. So iron donate electron to it, and we don't want this to happen. So what will happen is, because we know that metal, they can conduct electricity because of the mobile electron. So this electron is actually moving away around the zinc. And also for iron, actually is a kind of metal. So once these 2 electrons being donated to H2O and water and oxygen, so zinc will immediately give the electron to iron because they are conducting the electrons, and this one is more reactive compared to iron, so it will just donate the electrons to Fe 2+. So in other words, we don't have iron 2 form, and then the rusting will just stop. So similarly, if I replace it with magnesium, okay, so of course they are directly contacting with each other again. So again, similar thing. So it will protect iron. Okay, so that's the idea. So the more reactive metal themselves just sacrifice and to donate the electron to the less reactive iron. Okay, and then so that there's no rusting can be occur. Now then we can just go back to our notes again as a summary. Okay, so sacrificial protection means that when iron is contact with a more reactive metal, okay, such as magnesium, zinc, okay, so just a magnesium, zinc, calcium, sodium, potassium, but actually these are too reactive, so we seldom use them, okay, so then they would lose electrons, and then we say they are being sacrificed. Okay, for example, there's a ship. So on the ship, we have attached it with some of the more reactive metal. Okay, so it's much more like, okay, this is the ship, okay, and this is the more reactive metal attached to it. So once oxygen and water get the electrons away, and then the more reactive metal will donate electrons to iron. So that's why these pieces of zinc and magnesium will protect the ship body, okay, and prevent it from rusting. So if we totally cover, let's say for example, let's move back to galvanization zinc plating here. So before, okay, if there is a new bucket, okay, totally covered with zinc, of course it protects iron from rusting because they are totally protecting the iron and then avoid iron to contact with O2 and H2O directly. Okay, so this is by coating. However, even there's a broken part on the same, okay, on the same layer, okay, it doesn't matter because zinc will keep on donating the electrons to iron. So even it breaks, or just like using some small pieces of the more reactive metal directly contact on the iron object, so actually they can protect the iron object. Okay, so remember this one. I would like you to just take out your highlight pen, okay, point out these two. They are just be so important. So before broken, the zinc stop air and water reaching the iron underneath 下邊嗰啲啦, okay? But once it broken, it still protect the iron object by sacrificial protection. Okay, so it's the second, okay, the second example of using sacrificial protection is like this, okay? Like this. Okay, sorry, this one is much better. It looks better. So, if, okay, so there is a underground water pipe, okay, 條水管啦. So, what will happen? How to protect the underground water pipe is, if I have a block of magnesium, okay, and then I would like that magnesium to direct contact with my underground steel. So sometimes it may be quite difficult because it's underground, so it may be difficult to direct contact with it. So then there's a very good way to connect magnesium to the underground water pipe is by an other metal. So usually we use a insulated copper cable, insulator, 可能包住啲膠或者點樣啦. Okay, so even the copper cable would not oxidize because they are being protected by an insulated layer. So this magnesium will keep on donating electrons to the underground water pipe, and so that's why the iron water pipe actually would not rust because it's always keep protecting by the magnesium metal. So now once that magnesium metal being used up, and actually we can replace a new one, okay? So actually it depends on how long the metal cable is. This metal block actually can be on the ground, okay? It's not necessary to be buried underground. So once there's a connection, so no matter where you put it, that will be okay. So this is about sacrificial protection, okay? So please base on the picture I sent to you and then copy the wordings I just explained. And then the third method, okay, of preventing iron to become rust is by impulsed current cathodic protection. Now this name is actually quite difficult to remember, right? Okay, so I think we seldom ask you to memorize the full name, but you have to know the the principle behind. So what's the principle behind? Let's have a look about the diagram here. Okay, so detail about this setup will be mentioned in unit 19, okay? 19 and 22. Okay, so no worry too much. Okay, so now just have a brief idea. If we have a power supply, the negative terminal means that electron will be moved out from here. So if I have a battery, okay, so this part is the positive and this part is the negative. So there will be electrons keep on moving out from this end of battery. So once there is a negative terminal of our power supply, it means that electron will flow out from here, and then it will, if this is the iron object being protected, so these electrons are given to the iron object will prevent it to form iron 2. So that's why for this case, okay, no iron 2 will be formed. Okay, because there is a continuous supply of electron from the electricity source here, the power source here. Okay, so that's the idea. So the negative terminal, okay, is connected to the iron object being protected, and the iron object is called cathode. So for not the iron object, but this part is called cathode. So detail about this one will be learned later, so no need to worry too much. So sorry, I should say this is the cathode, okay? The negative terminal of my battery is the cathode. Okay, so now this one is the cathode. Sorry, I pointed to the wrong place. Okay, so cathode here and NO here. And then the last method is called Elnoying. Elnoy, that means mixing ion object with other substance inside. So the explanation, no need in our syllabus, okay, but I just give you a simple idea about the explanation here. So Elnoy of steel, okay, of iron to make steel is by mixing carbon with iron. So how come it can prevent rusting? Okay, remember, no need to know this explanation in DSC. Okay, so just a brief idea. So if electrons in ion object actually is mobile, right? And you remember if this O2 and H2O, okay, reaching the ion object, so these electrons will be donated to H2 and O2. But the idea is when it's mixed up with the other elements inside the ion object, so this, because this other substance, they have different size compared to my original ion. Let's say this is Fe, okay, and then this small size one is the carbon. So electrons, once they move quite freely, and then somehow they may be brought by the other elements atom, and this can prevent the electrons to be lost easily. So this is the idea. So once you mix iron with other elements, so they are having different size of atoms, and this will just like prevent the mobile electrons to move so freely, and then they prevent rusting. Have a look about your checkpoint on page 14, okay, 14 of your notes. So the 3 checkpoints here, okay. Firstly, which one is the best way to prevent iron wheels? Okay, so it's the moving part in machine. So you use oiling, that means greasing. Okay, and then which one is sacrificial protection? So sacrificial protection allowed iron to be protected by a more reactive metal, so just like zinc. Okay, so these are less reactive than iron, so they cannot protect iron object. And then, okay, which one cannot prevent iron from rusting? So this is Elnoying. Okay, that means mixed with other atoms of besides iron. So this is okay, Elnoying. Coated with something, coated with grease, coated with paint. These two are the suitable method. And then the last one is by connected to tin. Tin, where it is? Tin is just below iron. So tin has the symbol Sn. Okay, Sn. So it is less reactive than iron, so it can't protect iron, okay, from rusting. That's the idea. Okay, now once you know about what are the methods to prevent rusting, then just have a look about what are the factors that will speed up rusting. So there are totally 5 ways to speed up rusting. The first one is the control, that means no special treatment, okay, on the iron object. So now I'm talking about page 6 of your notes. Okay, so firstly, for control, you just put an iron nail in a boiling tube. So inside the air, okay, air inside the boiling tube, there are O2 and H2O present. So you just representing the normal situation, how I put iron nail in the air. The second one is by putting some seawater in the boiling tube. The next one is by putting some acidic pollutant with air in the boiling tube. Okay, so firstly, may we consider these two? Actually, they have a similar effect on iron object. So if there are seawater contain a lot of mobile ions, okay, for example, sodium chloride. So we found that, okay, if you still remember, for iron, okay, to donate electrons to O2 and H2O, okay, so this process, donating electrons to the two molecules, so this process much more like conducting electricity. So then, if there are presence of mobile ions, actually it will speed up that process. So detail is difficult to understand, because if you want to know that, then you may need the knowledge from unit 22, okay, to understand more. So in this chapter, you have to know that once there are mobile ions provided, then rusting will be speed up. Okay, so write down. Now, if the air containing acidic pollutant, okay, such as nitrogen dioxide and sulfur dioxide, So for these two gases, okay, they may mixed with the water moisture in the air, and then they will become the acidic substance, including HNO2. For HNO2, okay, so write down the name. Okay, it's called, oh sorry, I just reversed it. It is called, okay, maybe I just change. This is NO3. Okay, this is NO2. Okay. So HNO3 is called nitric acid. HNO2 is called nitrous acid. So if we call them acid, okay, then we just have a look about, do you remember HCl? Okay, I call it hydrochloric acid. So they are hydrogen ion and chloride ion present. So if there's a nitric acid, so the ions will be hydrogen ion and the nitrate ion. Okay, so these two ions will be, oh sorry, you can't see it clearly. Sorry, okay. Okay, so is it okay? So wait, okay. So these two ions will be present, okay, just like HCl, this case. Okay, so now once there are mobile ions present in acid, okay, for this one there will be hydrogen ion and, okay, so let me write down, there will be hydrogen ion and nitric ion. I hope you still remember, we learned about it in grade 9. Okay, so these two will provide mobile ions. For sulfur dioxide, when mixed with water, okay, it will form a new acid. Okay, you haven't learned before. I think you remember H2SO4. Okay, so this is called nitric acid. But now it's H2SO3, which is a weaker acid compared to nitric acid. So we call it sulfurous acid. Okay, so again, there will be, okay, H2SO3. There will be 2 hydrogen ion and 1 sulfur ion, okay, in the acid. So because mobile ions are present, so it also speeds up rusting. So last 3 cases are just easy to understand. Firstly, higher temperature. A higher temperature always increases every kind of chemical reaction, including rusting. Okay, and if the metal is contacting with, point 5, if the metal is being scratching or bending, okay, or the bending part of an object, okay, just like this one, okay, is bent. So the bended part will rust more easily. So if I bend something just like this, okay, if this is the iron object, okay, this is the iron object, and then I bend it, what will happen is the atoms here, they will weaken because of my force. So if this is iron, actually I'm providing some energy to break the metallic bond. So this part, actually the metallic bond will maybe weakened, and then it can be rust more easily, but the explanation is not required in our syllabus. Okay, so remember that will be okay. So iron object is bent, okay, scratched, that means 刮花, okay, 刮花咗啦. Okay, again, they weaken metallic bond and then rust more easily. Last one is by contacting with a less reactive metal. So idea is easy to understand, okay? So let's say copper, less reactive. And then let me use, let's say iron, okay? Iron, okay, the more reactive one. And then for H2 and H2O and oxygen, okay, so when they comes, okay? So they may get the electrons from copper, okay? And then what happens is iron will donate the electrons to protect copper because copper is a more stable metal. So if H2 and O2 come to that side, of course they will get the electrons from iron. So no matter H2 and O2 come to which side, it is iron that loses its electrons. So actually, in this case, we say iron protect copper, and then it will speed up rusting to occur. So please do the checkpoint yourself for the next page.